Okay, let's look at why even and odd functions are called even and odd functions. So an even function is symmetric about the y-axis, and so if I folded my graph at the y-axis, the right side would lay on top of the left side and so forth. So that's even functions. Well, let's look at some things like y equals a constant, and I'll just call it a, and well, that's kind of weird. So it doesn't realize that's a constant. It thinks it's a variable, and so I'll put in here that like a equals 1. Now it knows it's a constant, and I'll just go with the defaults, and we see that that graph y equals a is symmetric about the y-axis. If I fold along this vertical line here, this line will lay right on top of that one. Okay, how about y equals we'll go with a b, I guess, bx squared. And it says add slider, so sure, I'll add that. And notice no matter what the value of b, when I take this bx squared and so forth, I get something that is symmetric about the y-axis. Notice the exponent, it's 2. Up here I could say this is x to the 0, something like that, and notice the exponent, it's 0, right? So I have something like this, and actually let me change this to y0, and this one I will call y1, and or actually better yet, right, y2, and because then the exponents go together, and I'll do one more, y4 equals cx to the 4th, add my slider, and again you see that's symmetric, and no matter what I do, it stays symmetric. Now if I add a couple of symmetric things together, so let's put me down in this corner here, or at some point maybe get rid of me altogether, but okay, suppose I take y0 plus y2 plus y4, like that, and that's the green one. I could kind of hide these others so that I only see that one, and I could start sliding some things around, but you see, it stays symmetric. I could slide this one, and it stays symmetric. Slide this one, it just moves up and down, so it stays symmetric. So you see, if I take a polynomial, so this is something, it's a constant plus something times x squared plus something else times x to the 4th. If I take a polynomial that has all even powers of x, it's always symmetric about the y-axis. Even functions. Okay, so that's where that name comes from, even function. Now we could even try something like I'll just not say y equals, I'll just put the expression in here, and let's take what am I up to, d x to the -2, add my slider, and notice not even that, right? That one is symmetric about the y-axis. And so even with negative exponents, where I have -2, if I went to -4 and so forth, I keep getting these things that are symmetric about the y-axis. And so that's an even function, and that's where the name comes from. So kind of neat, right? You know, that's the property of these polynomials and just powers of x. As long as the power of x is even, I get something that's symmetric about x. If I add a bunch of those together, I still get something that's symmetric about the y-axis. Okay, so that's an even function. Now, if we look at odd, well, I'm just going to go in here and change that to a 1. I'll explicitly put a 1 there, and just for the heck of it, I'll put a 1 here. Now, of course, that doesn't know what we're talking about. And we'll go to 3 and a 3 here. So again, odd powers, and a 5 and a 5, and I'll show those. So I'll get rid of that one for the moment. And here's y equal some constant times x, and again, if I change that constant, it moves like this. But an odd function is one such that it's symmetric about the origin. So that is, if there's a point here, I should be able to draw a straight line through the origin and get a point there, the same distance away. Well, that's pretty obvious for y equals a constant times x, or x to the first. But now as you add x cubed in here, well, actually the y equal ax helps me see that, sure, that's the same case here, right? As I move my straight line, it keeps intersecting, you know, at points like this, and those are the same distance away, and the line goes through the origin. So it's that idea of an odd function. So that's what makes it an odd function. And again, if I, you know, start doing things like this, it's still an odd function if I move the slider around for the b and so forth. And then I go to x to the 5th, and same idea. You know, you see that we get this same sort of thing of symmetry through the origin. And so once again, we have that symmetry. And quiet, dog. I have puppies that are barking because people came home. So we have that symmetry through the origin, and you know, that's an odd function. Now let's change this to -1, and actually we see we get that same thing. I can move this slider around for that straight line and see that, you know, I'm still getting that same sort of property happening. So even negative odd exponents work. And if I come in here and hit enter, so I can enter my y1 plus y3 plus y5, and we enter that. Now let me get rid of these. Then again, you see that, well, maybe we'll keep that one and get rid of this one. But then again, you see as I move various parts of this, we still see those intersections along the line. Of course, moving that changes the line a bit. Ooh, how about that? Okay, so we see though that we still get, you know, wherever this line hits here, it hits through the origin the same distance over. So we get that odd function again. And so if you take these polynomial pieces, power functions, and we go with an odd power on x, even negative odd powers, we get that property that we call the property for odd functions. And again, that's where the name comes from. It comes from these powers on the polynomials. So that's where the name comes from, even and odd functions. But then, of course, some functions that are not polynomials are even and odd. So, for instance, sine of x, that's an odd function. If I get rid of that and kind of look at this line as it hits spots, I'm not very good with this mouse here. There we go. And we can see it's hitting, you know, the same distance, and it'll do that everywhere and go through the origin. Or if we take something like the cosine function, that one is an even function, and it's symmetric about the y-axis. Okay, so you can have sines and cosines or other functions that are even and odd functions, but the name, you know, where did that come from? It came from these powers on x. Okay, so if we take odd powers only of x, we will get an odd function. If we take even powers only, we will get an even function. So that's even and odd. And I guess that'll do for that video.